For this experiment, we are looking at the solubility of a couple of different substances in different solvents. We're going to look at the solubility as an expression of whether something is polar or nonpolar. So what we have is a polar solvent, water, and a nonpolar solvent, cyclohexane. We are going to be testing each of our solid and liquid samples, our solutes, in these two different solvents. I've already set up a couple of test tubes with small amounts of the solid in each one. A couple of them I still need to add a little bit of solid. Notice that I'm using very small amounts. This is because every solid is going to run into something called a saturation point. If we oversaturate our solution, not all of it is going to dissolve. Once I get the rest of the solids in here, we will be looking at adding the two solvents and comparing which one does a better job of dissolving our solutes. So I'm going to add some ethanol to my ethanol test tubes. This is a liquid solute. I'm going to add about 1 milliliter to each of these test tubes so we can see, again, by comparison, which solvent does a better job of dissolving our solutes. Now, if we have a liquid dissolving in another liquid, it's a slightly different situation than when we have a solid dissolving in a liquid. With a liquid, we can either have something miscible or immiscible. And miscible liquids are going to be able to dissolve in each other in any proportion, so we don't have to worry too much about a saturation point here. Now, in some versions of this lab, we test coconut oil, and in other versions, we also test iodine. So what I have here is a little bit of iodine, and I'm going to use very, very small amounts of it to do this test. And again, I'm trying to make sure that it's roughly equal amounts in both test tubes so that we can compare apples to apples. Now it's time to add the solvent. I'm going to add about a milliliter of solvent to each of these test tubes. The exact quantity isn't that important as long as we have equal amounts. So I'm using the height of the liquid in the test tube to gauge how much I've put in. So there's already liquid in there, that's why it's going so high up. And then about there. So what I'm going to do is kind of swirl these vigorously to get good mixing, if they're able to mix, and then we're going to see what's left. This is our sodium chloride in water. Here we have coconut oil in water. I'm going to swirl that around pretty vigorously and see what we get. Okay. Next is the iodine. This one is sometimes a bit interesting. I like to put something white behind it so you can see something a little bit interesting going on there. The iodine sort of very faintly colors the water. And then we have ethanol and water. Now, in order to tell whether these are mixed, we are going to look at this liquid very closely to see if it is one single liquid or if it's two separate layers. And so tilting the test tube like this kind of helps us look for any sort of double meniscus and see if we actually have two layers or just a single layer of ethanol and water. Okay. And then finally, we have sugar, good old sucrose. We'll mix this vigorously just like we did the salt. Let's see what we have. And be sure to compare this to what we saw in the beginning, right? In the beginning, we had small amounts of the solid in each of these test tubes. Okay. So that is the water solvent. Now we're going to compare this with cyclohexane. Now, cyclohexane is a very volatile solute or solvent. That's why we have the parafilm around the cap. Generally, you want to work with this stuff with good ventilation. So I'm going to add, again, about 1 milliliter to each of these test tubes. And we'll take a closer look at each one to see what's going on there. So these test tubes that I have marked in yellow, I've added the cyclohexane solvent to our solutes. This was the sodium chloride. Now, take a close look, see what you can see in terms of the solid. We may even pan up above a little bit so you can see what's going on in that test tube. So again, this is the sodium chloride and the cyclohexane. Next up we have the coconut oil. We'll mix this vigorously. The flicking technique, if you've never seen it before. And we'll take a look at what's going on in there. In some cases we do hit a bit of a saturation point, so we want to compare what we had initially and what we had before. If we compare what we saw with the coconut oil in the water, it's a lot easier to tell the difference. So the blue label is the water solvent and the yellow label is the cyclohexane solvent. Both of these contain coconut oil. Next up is the iodine. Now this one's pretty interesting. Again, we'll use a white background here. Take a look. There's definitely a difference from what we saw with the water solvent. And then finally, our ethanol. Now this one, you might have to look real close. Try and put this on the black background because that's probably the easiest to see. And we'll tilt this around so you can look for any double layer that might be present. And if we try and get this to mix, what we end up with is something that we call a dispersion or a emulsion. It may temporarily suspend, but it eventually starts forming these little beads. And then finally, our sugar. Now the cyclohexane is starting to evaporate away, so the solvent's getting a little bit low, but you can kind of see what's going on in there and compare what we saw with the water. Just so that we can see the difference. And we'll also look at cyclohexane and water together so you can kind of see what it is you're looking for two immiscible liquids. So 1 milliliter, thereabouts, of the cyclohexane, and we'll add about 1 milliliter of water to that. So these two liquids do not like to mix. Water is polar, while cyclohexane is nonpolar. So you can see that double layer there. So this is what we're looking for when we're deciding whether a liquid is immiscible. So again, comparing the ethanol and the cyclohexane in the two different solvents. The yellow tape is the cyclohexane, the blue tape is the water. And then to go through our solids again, the sodium chloride. The coconut oil. The iodine. We already saw the ethanol, and then finally we have the sugar. Okay, the next leg of this experiment with solubility, we are going to look at some unknowns, and we're going to use their relative solubility in the two solvents to decide whether they are ionic or polar, or whether they're nonpolar. So I have unknown A here. You can see inside what this looks like. And then we have unknown B, which you can see in here. Looks like this. And I've already doled out roughly equal portions into the two test tubes for water and the two test tubes for cyclohexane. Again, we're going to keep the color scheme pretty consistent. All that's left is to add the solvents and then see which one does a better job at dissolving our solutes. Add the cyclohexane solvent first to our yellow marked test tubes. Again, about 1 milliliter of cyclohexane in each one. And since these are solids, we're probably going to add a little bit of kinetic energy to get things started. So as you can see from the labels, on the left I have unknown A, and on the right I have unknown B. So let's take a top-down view a little bit to see what's going on in there. So you can see whether our solids are dissolving or not. We'll add roughly the same amount now of water to our other set of test tubes. So we'll add about 1 milliliter. Again, I'm trying to make sure that I'm just getting the same volume, roughly the same volume in each of these test tubes. And so we can kind of swirl these around a little bit, see what's going on. Now we're running into a little bit of an issue with unknown B. So take a look at what's going on at the surface there for unknown B. See if you can spot the issue. And if we take a look at unknown A, over here on the left, doesn't look like we have any issue at all. So for comparison, again, we'll take a look at cyclohexane versus water. So we'll compare unknown A in the water, unknown A in the cyclohexane. Which solvent did a better job of dissolving our solid, our unknown A? And then comparing cyclohexane and water with unknown B, which did a better job of dissolving it. See if you can tell which one did a better job of dissolving unknown B. Okay, and that should be it for our polar and nonpolar segment.